Okay, we're back. We're doing, this is Math 200. We're in Chapter 6. We're doing 6.3 from the note packet. That is page 8 on the note packet. And this is factoring by special products. And now, you know, with math, it doesn't always, as you go on, it doesn't always mean it gets more difficult. Like factoring special products is easier than factoring like what we did on section 6.2. For sure, the second half where we had to do the AC method over and over again. All right, this is a lot easier than that because it's factoring. We're still busting it down into its smallest pieces, but it's they give you like an algorithm. They give you a method to do it, and you just do that every time. And so it's easier factoring. You don't have to rack your brain. It's even easier than unfoil factoring, where you had to figure out what multiplies to be the last thing and adds to be the middle thing. And so even though it looks harder, because on some of these you're like, oh no, it's a 16 and it's a 4, so I'm going to have to AC method it. No, because they tell us these are perfect square trinomials. That means it's the same binomial times the same binomial, which means to factor it, you just have to know how to take the square root of stuff. So the square root of x squared, that's just x. The square root of 36, that's just 6. Those are my factors. That's it. I'm done. I just x plus 6, done. X plus 6 times x plus 6 is that. Now you can check the middle term if you'd like. Remember 6x and then positive 6x, that is 12x. X times x is x squared, 6 times 6 is 36. All right? So it's a lot easier. If they tell you ahead of time it's a perfect square trinomial, factoring is a walk in the park. It's just as easy as doing the square root. So what times itself gives you 16x squared, that would be 4x times 4x. What times itself gives you y squared, that would be y. And you're done. It's oh, there is one part. Okay. So wait, I'm selling it to be too easy. So we go 4x and y, and we go 4x and y, but now here's the $1 million question on this. It's got to be the same thing times itself, but should it be plus plus or should it be minus minus? That's the question right now. And if you just said to the screen minus minus, you are correct. Because look, that had to be plus plus because it had to add up to positive 12. This has to be minus minus because it has to add up to negative 8xy. And it does. Negative 4xy and negative 4xy is negative 8xy. So there is a little more to it than just taking the square root. It's the square root and getting the correct sign. Most students, though, in my career have said it's still way easier than even unfoil factoring. Okay, so here we go again. 4m to the 4th. We want the square root of that. So that's a little tricky, right? 2m squared. And the square root of 1 is 1. Lots of people kind of mess that up. They don't look at 1 as a perfect square. It is a perfect square. And so we write down our 2m squared, 1, our 2m squared, and 1. And now here's the $1 million question. Plus plus or minus minus? And the answer again is minus minus, because it's negative 4m squared in the middle. All right. And then this one, we do the square root of 25x squared, 5x, and the square root of 9, 3. Except this one they gave us, that doesn't work, because look, 5x plus 3, 5x plus 3, that turns out to be 15x and 15x, which is 30x. That is not a 30, that is a 50. This one is prime. So they snuck a prime in there on us on number 3. And if they tell you ahead of time it's a perfect square trinomial, then there shouldn't be a prime one in there, all right? So that was a little bit of a weird one to put into the perfect square trinomials. I think the idea of the note packets here is just that anytime you can't factor it, no matter what the scenario, it's prime. All right? So let's look at 6.3 on the next page. It's the difference of two perfect squares. And now some students, my students of the past, have told me they think that's easier than this that I just erased, what I just erased, because there's a little less thinking involved. When it's the difference of two perfect squares, you do them similar to the problems that we just looked at. In that you do it as square roots. But again with the prime, they stuck a prime in on us. Okay, so let's do the difference of two perfect squares. So this is a perfect square and a perfect square, and there is no middle term. There's not an x term. There's not an x term. There's not an a b term. There's not a y term. There's not an x4, y3 term. So they're missing the middle term. Well, why are they missing the middle term? Because these always factor into conjugates. Look, you take the square root of x squared, that's x. You take the square root of 9, that's 3. And now you write that down, x3 as two binomials. But now this is always true. It's always a plus and a minus. The fancy math term for that is conjugate. Those are conjugates. Conjugates are not opposites. I had students say, why do you guys always make everything tough? It's opposites. It isn't. Opposite would be negative x minus 3. Only one of the signs is changed. That's why it's a conjugate. And whenever you multiply a conjugate by, when you multiply conjugates, the middle term goes away. Because look, you get x squared, you get minus 3x, you get plus 3x, you get minus 9, so the minus 3x and plus 3x go away. That's why there is no x term. It's x squared plus 0x minus 9. All right? Same dog, different fleas. So 2x plus 1 and 2x minus 1. And so you get to the point with these where you don't even have to do this work. You can just take the square root in your head. And so that's why most students find these to be pretty easy compared to the other one. I mean, nothing is super easy in algebra, but 6a plus 7b, 6a minus 7b. Just as long as there's one of each, the middle term goes away. So 42ab and minus 42ab, that's why there is no ab term. All right? And again, you'll get good at it here. The square root of y squared is y. The square root of 16 25ths. Now remember, that's like the square root of 16 over the square root of 25, which is 4/5. So we got y plus 4/5. We got y minus 4/5. And that's our answer. X to the 8th. So when you take the square root of x to the 8th, you got to remember how that works. When you take the square root of something with a higher power on it other than squared, you divide it by 2. You divide the power by 2. So 8 divided by 2 is 4. That does make sense because when you multiply things with like bases, you add exponents. So x to the 4th times x to the 4th is x to the 8th. Y to the 6th. So that's the square root of y to the 6th is y to the 3rd. And there's our answer, x to the 4th plus y to the 3rd times quantity x to the 4th minus y to the 3rd. And we're done. This one's prime. Again with the primes. They love putting a prime on each page apparently. Prime, you can't do that. It's a plus. It's got to be the difference of two perfect squares. If you think, I've had students tell me, no, do x plus 2x minus 2. Well, if I do that, a plus times a negative is a -4, not a +4. And then they're like, well, just make them both pluses. Well, yeah, okay, but then I get a middle term. If I got x plus 2 times x plus 2, the middle terms don't cancel out. I end up with x squared plus 2x plus 2x plus 4. And then that adds up to be 4x. And that's not what's there. So it's prime. It's got to be the difference of two perfect squares, all right? Let's take a look at number 8. That's the last one on that page. So even when they throw bigger numbers at you, you get to use your calculator. So you can just default to the little electronic helper. But in this case, neither one of these are perfect squares right now. The sixth, huh? And so those are going to be, oh, I see. So we factor out a 3. So this is a lead-in. So we're out of the difference of perfect squares. I can factor out a 3 because look, 2 plus 4 is 6. 6 is divisible by 3, so 24 is divisible by 3. 3 plus 7 plus 5. 3 plus 7 plus 5, that's 15. If 15 is divisible by 3, so is 375. 15 is divisible by 3, 3 times 5. And so that's a trick you can always use. That only works for divisibility by 3. So you can add up the digits of any number, and if you get a number that's divisible by 3 when you add up the digits, then the original number is divisible by 3. That's a neat little trick to carry through here. So 3y cubed comes out. That is my greatest common factor. So 3y cubed, 3y cubed. So I end up with this is 125y cubed, and this ends up as 8. Still got the minus. So this is a perfect cube. So is 8 is a perfect cube. What do I mean by a perfect cube? What I mean is 8 could be written as 2 times 2 times 2, or 2 to the third power. 125y cubed could be written as 5y times 5y times 5y, or 5y to the third power. All right? And that's factorable. The difference of perfect cubes and the sum of perfect cubes are factorable. And so let's take a look at what those factors look like. We got 3y cubed. Write them out as perfect cubes. So we have 5y to the third power minus 2 to the third power. And then after that, it's an algorithm. There is a method to break these down. It's always going to be a binomial times a trinomial. And I'll show you how to populate those. So the 3y cubed is hanging out front here. There's a binomial times a trinomial. And so now your test is going to be open book, so it's not going to, you don't have to memorize it. But back in the day of memorizing it here, it was whenever it's a minus, whenever it's a difference, you put in the sign. So you go minus, plus, plus. That's always true. When it's a minus, the difference of perfect cubes, it's a minus, plus, plus. When it's a plus there, if that was a plus, then it becomes a minus sandwich with plus bread, meaning plus, minus, plus. All right? After that, now we just stick the stuff in there. Now let me tell you how we get that stuff. This goes right there, 5y. The cube root of that number is always the number that goes there. The cube root of that number is always the number that goes right there. How do I do this one? The first number in the trinomial is whatever this number is times itself. So 5y times 5y. 5y times 5y is 25y squared. The last number is always whatever this number is times itself. 2 times 2, which is 4. And the middle number is those times each other, so 2 times 5y, 10y. And that's it. We're done. You factored. And so it's a lot like just a process. We are factoring, but again, most of my students in the past have found these problems to be easier, even though it looks a lot more complicated on the face of things, right? It looks like it's a lot harder of a problem with the work that I showed, but at the end of the day, it's just you're pulling numbers, taking it times itself for that one, taking it times itself for that one, taking it times each other for that one. And so here, let's do some examples of these, and hopefully by the end of our examples, you'll think, yeah, that's not that bad. So here, we got x cubed plus 1. So here, we're going to write it as perfect cubes. And then it's a binomial times a trinomial. And you put in, look, when it's a plus, we go with this sequence, plus, minus, plus. And now whatever numbers are right there, you put down x and 1. This is that number times itself, x squared. This is that number times itself, 1 times 1 is 1. And this is the numbers times each other, so 1x. And you're done. That's it. Done. Factored. Okay? So like I said, it's a kind of a set rules to do it. This is the toughest part of it, I think, is getting it down into perfect cubes. Now, that was pretty easy. You just put a parentheses and that's cubed. But then you got to take the cube root of 64. And now, so with your calculator, if you want, you can go 64, go power, parenthesis 1 divided by 3. Things to the 1/3 power is the cube root. And then hit enter, and that's 4. So minus 4 cubed. After you get it down into a perfect cube minus a perfect cube, it's easy peasy lemon squeezy. It's a binomial times a trinomial. When it's a minus, that means minus plus plus. And now whatever number I have there goes there. Whatever number I have there goes there. This number times itself goes there. This number times itself goes last. And times each other goes in the middle. And that's it. Done. Always the same process over and over and over again. So now 8t cubed plus s to the 6th. Okay, so that's a little trickier because powers, right? Powers are a little weird. So this one is 2t to the 3rd power. 2t times 2t times 2t is 8t cubed. Plus, when I take the cube root of s to the 6th, I divide by 3. 6 divided by 3 is s squared to the 3rd power. Because remember, when you have a power raised to a power, you multiply. So 3 times 2 is 6. So there it is. And now, that's the hard part. The easy part is it's a plus. So that means plus, minus, plus. And now you just populate it with this stuff. The cube root of that goes here, 2t. The cube root of that goes here, s squared. 2t times 2t is 4t squared. That's what goes in the lead of the trinomial. The last term of the trinomial, s squared times s squared, is s to the 4th. And then times each other is 2t s squared. Okay? Lovely jubbly. All right, then let's do a couple more problems. X cubed, y to the 6th minus 27z cubed. So, cube root of that, cube root of that. And there's a minus in between. So divide by 3, that's x to the 1st, y to the 2nd. The cube root of 27, take 27 to the 1/3 power in your calculator, hit enter, and it should tell you 3z. And here we go. It's a minus plus plus, and xy squared, 3z. xy squared goes there, 3z goes there. That times itself is x squared y 4. That times itself is 9z squared. And those times each other are 3xy squared z. Don't forget the z. I didn't leave enough room in the middle there. I had to make them really scrunched down. Doesn't matter what order you put it. You could say 3z xy squared or any version of it. Just make sure the squared is on the y. All right. And then number 5, x cubed minus 2x squared minus 36x plus 72. Ho! So that's 4 terms. So let's factor by grouping, right? 1, 2, 3, 4 terms. So we'll factor by grouping. Oh, what can we pull out of the first 2? That would be an x squared. Oh man, bones are creepy. X minus 2. And then what do we have to factor out of the second 2? A negative 36. Negative 36, negative 36. Now, because I knew I wanted a 2 there, and half of 72 is 36, so it works. So x minus 2. And so now you might say, well, what are they getting up to here? Why do they give me a factor by grouping? Well, see, now look, x minus 2 comes out. And then we're left with x squared minus 36. So now it's like those infomercials at 2 in the morning. But wait, there's more, right? There's more. X squared minus 36 is the difference of 2 perfect squares. So I take the square root of x squared, that's x. The square root of 36, that's 6. And then a plus and a minus. Sweet. So we took a 3rd degree equation and we busted it down into 1, 2, 3 little pieces. Nice. I'm hoping you're feeling mathletic after you did that problem. So let's do the last one on this section is another factor by grouping. See what they have in store for us here. We've got 2a cubed minus 90 minus 18a plus 10a squared. So we could factor out can't we factor out something out of all of those? A 2? Yeah. Yeah, we can factor a 2 out of everything for starters. So let's do that. On my key, I didn't do that until the end. I should have did that right away. It would make it a little easier. So now we got a cubed minus 45 minus 9a plus 5a squared. And now we have to rearrange it. Let's rearrange it. So we're going to put this one, we'll put it in descending order, basically. So we got a cubed plus 5a squared minus 9a minus 45. Easier to look at. Now, what can we factor out of the first 2? That would be a squared. So we're still doing factoring by grouping. A plus 5. What do we factor out of the second 2? That would be a negative 9. And that's still a plus 5. Right? Negative divided by negative is positive. Negative divided by negative is positive. So now we got those a plus 5s. And then an empty set. Let's cancel, and we get a squared minus 9. Oh no, but wait, there's more. Because now we have a perfect square minus a perfect square. So a plus 5. A 3 plus and minus. Holy Toledo. That's a heck of a problem too. So a little harder than this one because they stuck a 2 in that we had to factor out right off the bat. But again, we took a 3rd degree equation and we busted it down into 3 1st degree parts. All right. We'll do 6.4 next.